So now we go to B11, and this is the law of sines. Now for the law of sines, let's construct a triangle. I'm going to construct a triangle where there's a right angle here. And we have a side here we'll call C. We'll call this C. All right. And we'll call this, well, side H, the height. And I want to have some kind of arbitrary triangle because I want to do this formula for an arbitrary triangle. So I have one here that nothing special, like there's no 90 degrees here. So I have alpha here. We'll call this side A. And then we have beta up here. And we'll call this side B. Now this is B is just this, part in here like that. And we'll call this, let's go ahead and call this angle phi. Now we don't usually worry about double arcs and things, so they're all going to have one arc. And then here we'll call this gamma. All right, so we have alpha, beta, gamma. Gamma is opposite C. The logic here is that if you have side A, the angle opposite is alpha, like the first letter of the alphabet, Greek or Latin. That if you have B, the opposite is the angle beta. And then for C, you have gamma. So just like you have A, B, C, you have alpha, beta, gamma. So then this is phi. This is another triangle here. I just did to straighten this out as a right triangle there, and H. Haven't used it yet. So what we're going to say here is we're going to start here saying that H is equal to C, the hypotenuse, times the sine of alpha. All right, now let's look at this again a little more carefully. If you look at this big triangle here, it's a right triangle, and the opposite side for that alpha is H, and this is the hypotenuse. So the sine of alpha would be H over C, but we're going to write that as H is C times sine of alpha. So it's nice to be able to do that quickly either way. But now notice that if we do this, that we look at this triangle in here. This triangle has a hypotenuse A, but H is opposite that phi. So therefore, this is also equal to A times the sine of phi. So A times the sine of phi gets you this, but C times the sine of alpha gets you the same thing. Now, when we did the unit circle earlier with an angle that was bigger than 90, let's do the same thing here, where we have, say, Y going up here, where this gamma, see that gamma there? That gamma is bigger than 90, so say this is our gamma, like that. Then the other angle that makes up the 180 would be phi, so we would have phi here. So if we did, in this case, looking at, say, a unit circle, so we'll call this 1, radius is 1, then the sine of this big angle, alpha, that's the sine there, that would be your height going up. That's equal to the sine of just that angle in there. See, that would be here, and if you were, wanted to be really picky, we would say if we want this angle here with the phi, we have to put it in standard, position, measuring it relative to the x-axis. So if you put that phi in standard position, measuring from the x-axis like this, where we set things up the standard way, and this is 1, then the sine of phi is the same height as the sine of gamma. It's the same height. We're going to need this. The sine of gamma is equal to the sine of phi. So when you have angles that are, we say, supplementary, when the sum equals 180, the sine is the same. Because when you go here, these equal 180, when you add them together, the sine here is this height, and in standard position, if you put the phi here, it's the same height. Unlike the cosine, where here the cosine would be negative for the big angle, but positive for the small angle, like we did in the previous section. So we're gonna need this, and if we look at this and make the substitution, the wonderful thing happens. We have C sine of alpha equals A sine of gamma. But then what I'm going to do is bring the C under to go with the gamma, and I want the A to go with the alpha. So I have sine of alpha. I divide both sides by A times C. So this would give me alpha, and this would give me gamma over C. So you bring the A over to the left underneath it, you divide both sides by A, you would get this with the C still hanging around, but if I divide by the C also, then I get rid of the C and it comes over here. What's nice about that is that these angles are coordinated. In other words, alpha goes with A and the gamma goes with C, and you simply take the sine of the angle divided by the side that's opposite it. So, you could also, flip these and have the sine on the bottom like this, and C over the sine gamma. That's a cool result also. So the third angle can be worked out with a similar example, a similar analysis that we did here. So the law of sines, we could write sine of alpha over A equals sine of beta over B equals sine of gamma over C. And an alternative form is to do the reciprocal. So this is B over the sine of beta, and this is C over the sine of gamma. There you have it. The law of sines. Very important. Comes in handy in doing problems.